We often mistake computation for magic, an invisible, weightless abstraction that exists solely in the mind or the cloud. But before a single piece of software runs, before any abstract logic takes hold, computation is fiercely physical. It begins as raw hardware. It is a world of surface-mount components anchored to fiberglass, where precise copper traces route actual voltage across a custom board. Before an operating system can even think about booting, physical power rails must energize. Microcontrollers wake up, pins are pulled high or low, and diagnostic LEDs flash to trace the initialization sequence. We are taking sand, refining it into silicon, and intricately patterning it to channel electricity. Every abstract digital action requires forcing literal electrons down microscopic highways. The digital world is not a spell we cast. It is an electrical reality, heavily grounded in physical architecture and raw matter. The universe marches toward chaos. Every star bleeds energy, every physical structure decays, and entropy reigns supreme. Yet we persist. We build complex circuits, organize data, and force physical matter to obey our logic, fighting a deliberate war against the natural order of disorder. The very definition of life and consciousness is a localized reduction of entropy. Every heartbeat and every processed thought burns metabolic fuel to maintain a highly ordered state against the overwhelming push of decay. We are not merely observers of this cosmic disintegration. We are active participants rebelling against it, building structures that temporarily stave off the inevitable. Every technological leap is a new weapon in this rebellion. Silicon is our latest canvas upon which we etch our refusal to accept the universe's natural trajectory. Every bit flipped and every calculation performed is a testament to human defiance, a way of forcing matter to hold on to knowledge against the relentless push of disintegration. But this rebellion now demands an unprecedented planetary cost. Historically, the human brain engaged in this fight powered by the gentle flux of the sun, fueled naturally by the biological energy cycle of photosynthesis. Even the preservation of our knowledge reflected this sustainable balance. A printed book is passive. It holds our collective memory and transmits our ideas without demanding a constant flow of energy to remain legible. In contrast, the digital realm requires an active, energetic defense against noise. To access information, to spin up a hard drive, power solid-state storage, or automate a decision, we demand physical computational work. According to the laws of thermodynamics, this cognitive work cannot be separated from energy dissipation and heat. To fuel this mechanization of cognitive labor, we have fractured our balance with the Earth. We no longer rely solely on the energy available to us from the sun. Instead, we pull energy from beneath the crust, mining oceans of ancient carbon to feed 1 trillion thirsty processors. Just as the Industrial Revolution mechanized physical labor, the Silicon Age is attempting to digitize the collective unconscious at a massive thermodynamic price. We are burning through borrowed subterranean time, trading the Earth's stored reserves for a highly ordered digital realm, embarking on an unsustainable fever dream against an immutable clock. To understand the depth of this cost, we have to look at the exact nature of the work a computer performs and confront a profoundly uneven trade. The exchange rate between thermodynamic energy and informational value is fundamentally asymmetrical. Consider a machine simply sitting idle. Before it ever executes a meaningful command or automates a single decision, it is already burning fuel just to tread water. To keep an operating system alive is to wage a continuous, high-speed war against baseline physical decay. Billions of times a second, a clock pulses. Volatile memory states are aggressively refreshed before their electrical charges can bleed away into the noise. Background threads are scheduled, ports are continuously polled, and logic gates are held in artificial tension. All of this requires a relentless stream of physical energy, yet it produces zero new informational value. It is pure thermodynamic overhead, the immense energetic tax we pay simply to keep the silicon canvas from collapsing back into chaos. And what happens when the machine actually does work? When it executes a compiled sequence, processes a localized signal, or automates a decision, we face the core inequality of the digital age. We are burning tangible, finite potential energy, extracted from beneath the Earth's crust, to generate an abstract, weightless pattern. We can easily quantify the physical cost: the joules consumed, the carbon emitted, the waste heat radiating from the chassis. But how do we quantify the physical value of the resulting information? The heat is real. It literally warms the server room, an undeniable physical byproduct of matter resisting entropy. The computational decision, however, exists entirely in the abstract. It cannot plow a field, it cannot physically sustain a biological organism, and its value is strictly defined by human utility. This is the uneven trade. We are taking the Earth's hardest, most finite physical currency and converting it into transient, subjective logic. We justify this massive physical dissipation by pointing to the cognitive value of the output, but the universe does not recognize cognitive value. It only recognizes thermodynamics. We are trading actual ancient, stored power for an illusion of permanent order, leaving nothing but waste heat behind in the physical realm. To call it merely an addiction is to sell short the profound, if flawed, ambition of the human species. If we take the generous view, we keep feeding this furnace not out of blind compulsion, but out of a desperate, beautiful desire to extract the signal from the noise. The universe is fundamentally a sea of chaotic static. For the entirety of human history, we have been trying to make sense of it, to capture fleeting waveforms of meaning, to isolate the frequencies of truth, and to weave a coherent narrative from the raw, disorganized inputs of reality. Our silicon architecture is simply the most powerful filter we have ever built to perform this signal processing on a planetary scale. We make this uneven trade because, to us, the abstract logic is the point. We are willing to burn ancient, finite physical energy if it means we can process the insurmountable data of existence into something we can understand. We are trading the heat of the Earth to amplify the human voice, to synchronize our collective timelines, and to build a framework where knowledge can be synthesized faster than it decays. The thermodynamic cost is staggering, but the alternative is to surrender to the static. We keep treading water, keeping the operating systems alive and the logic gates in tension, because we believe that somewhere inside all of those automated decisions, we are moving closer to a permanent resonance, a localized harmony that might just mean something long after the hardware itself powers down.